team is ready for building the house. Here comes the implementation part, and this is the best part of this project as the students are involved in construction. This whole house was built by students. Whatever we designed on paper was practically implemented by us on site. And I would like to mention that I was part of this house construction, and I would say that it was the best experience of my life. The learnings are more than what all I have studied till now. Our marketing and communication team carry out many activities throughout the year. We participate in various knowledge exchange programs and have interactions with people. We organize social media pages. Next slide. Over the years, we have received recognition from the media for our work and also have interactions with various government officials and scientists. As this is a huge budget project, we do require financial support. Below are the sponsors who supported us in 2018. Next. Yeah. So these are the sponsors for the 2014 team. Next slide. Yeah. Here are our faculty advisors who are always there to motivate us and guide us through all the projects. Without them, reaching this level would be very difficult. And finally, this is the team participating in Solar Decathlon Design Challenge 2021 happening in Colorado, US. To get more updates about our participation, please do follow us on social media pages. Thank you. For any queries, you can contact us on mentioned email IDs.
Thank you, Bhavya, for your insights about the team. Now it's time to introduce the speaker of today's session, Mr. Kedar Deshmukh. He is a researcher at NCPRE, National Center for Photovoltaic Research and Education at IIT Bombay. After completing his bachelor's studies in mechanical engineering from BITS, Goa, he worked in Spicer India Limited, an automotive component supplier, as process engineer in quality control and new product development. Post his stint in the industry, he started a solar EPC company with a friend from college. Alongside the startup, he pursued masters in energy technology from Pune University. After graduating with gold medal from Pune University, he started working at NCPRE as senior research fellow with Module Reliability Group. His main role in NCPRE is to conduct field tests of solar PV modules and assessing their performance. Kedar is also certified energy auditor from Bureau of Energy Efficiency. He is a part of electrical subsystem of Team Shunya at IIT Bombay. Now, I request Mr. Kedar Deshmukh to give his valuable inputs on today's topic.
Thank you, Sakshi. So, yeah, we'll begin our today's session. I'll just put forward my slides. Okay. So, yeah, today's session we'll discuss opportunities in solar photovoltaics. So, broadly, the session would be in three parts. So one, I'll discuss some fundamentals of photovoltaics in very brief, and then we'll look at current opportunities that are available in solar photovoltaics, and then we'll also have a look at what are upcoming opportunities maybe a few years down the line that we can look at. So yeah, so before we start, this is just a question for you guys to ponder over. So currently in India, we have generation capacity of electricity at roughly 373 gigawatts, sorry. And let's say if we were to transition the entire generation to 100% solar photovoltaic, and assuming that solar works for 4 hours typically in a day, and giving it a 6 times penalty to make 24 hours of operation possible, what do you think would be the percentage of land area required? So if you guys could just type it in the chat box. Okay. So I do see a few responses, typically saying 1% or 10%. So let's just look at the numbers. So it would be close to 1%. So you can see here how the calculation goes. So even if you assume 6 times the nameplate capacity that we would want in solar, so that would roughly come to 2,240 gigawatt hours. And for 1 megawatt peak, roughly you require 0.012 square kilometers of area. So when you multiply the two, you get total area requirement would be close to 27,300, and percentage of land that comes to 0.83%. So that's even less than 1%. And that is if we have to transition today's installed capacity. And to give you a perspective again, Thar Desert, that is the desert in Rajasthan and Gujarat that we have, roughly has area of about 2 lakh square kilometers. 30,000 square kilometers is in Pakistan, remaining 1,70,000 square kilometers we have it in India. And if we can fit all of this generation capacity only in the Rajasthan desert, and it would require, if we have to make it in a square, the square would have a side of 165 kilometers. So I'll show it to you in the map. So the blue square that you see is roughly the area that you would need to power to replace our entire generation capacity one to one with solar. Now, the fun fact is, even though our installed capacity is 373 gigawatt hours, our current peak capacity is peak load is actually only 185 gigawatt hours, so less than half of the installed capacity. So we would require much lesser area even if we have to transition our entire electricity generation today to solar. And this slide just shows us that, and that was the main point of this exercise, to show that land is definitely not a constraint. We have enough desert land, and no one is saying us, no one has asked us to put all our solar in desert. We can put it right on top of our roofs. Our needs presently. Okay, so let's move on to the fundamentals part. So modularity is very fundamental to the nature of solar. Modularity means a group of something makes the larger thing, and the group of those larger things can make something even larger. So we'll have a look. So the very building block of solar is a solar cell. Typically, it is 15 centimeter by 15 centimeter cell, but the latest technologies will take it up to 21 centimeter by 21 centimeter square as well. So that we are going to see in coming days. But typically, you can see the order of the cells is around tens of centimeters, 15 centimeter, 20 centimeter. Now, when you add multiple of these cells together into a module, you get a module like this, which is typically on order of meters. So 1 meter by 2 meter is a typical size for 350 watt peak modules. So you have roughly 60 or 72 cells in these modules. You also have smaller modules that are specifically designed for different applications. You would have seen something like smaller panels for solar street lights or in weather monitoring stations. So these are typically smaller panels, very particularly designed for charging the batteries in those systems. Okay. Then these modules you can put in series and get a higher voltage, and you make an array. So typically an array is a system that would suffice for a residential purpose. So 4 panels, 8 panels. You could go, depending on your consumption, you could go as high as you want. But typically, a couple of arrays or maybe 3 or 4 arrays would be sufficient for a residential kind of a system. You would need a little larger, maybe 30-40 arrays or up to hundreds of arrays for commercial or industrial rooftop systems. And when you go to large scale power plants, you have hundreds and hundreds, if actually thousands of arrays if it goes into tens of megawatts. So after arrays, then you combine multiple of such arrays, and in a large scale power plant, you get something that is called a block in the industry. So a block is basically combination of all the arrays and its subsystems, along with typically an inverter and a transformer. So that forms a building block for a larger solar power plant. So in this case, the image that I've shown is basically a cropped out image from a plant that we will see. And this this image shows us 3 blocks. So typically when you see such locations without panels, but there is some roof tin shed type of a thing, this will basically be housing inverter, generally 2 inverters of 5 megawatts each. That is becoming the norm nowadays for large scale power plants. So typically one block will have a 10 megawatts of capacity, and it will have it will have 2 inverters and a transformer as well, so in the same area. So in this thing you can see around 3 blocks, so 2.5 actually. Some portion of this is in the next, you'll see in the next slide. So do mark this red line on the right hand side. In this slide, this is to a scale of 50 meters that I have marked. Okay. Now next slide we'll see. So here you can see this is the block that we had zoomed in on, and you can see there are multiple such blocks. So typically when you're designing a solar power plant nowadays, you design one block and you actually do a copy paste of the same, so that you reduce errors in designing, as well as if your terrain is flat, like this is in Rajasthan. So if your terrain is flat, you can just replicate the same even mechanically on the ground. So you just have to do copy paste of it, which is quite simple. So okay. Yeah, I forgot to show you. So this red line here is of an order of 100 meters. Okay. Now, so I would like to point out this small solar plant on top left corner is what we were looking at previously. Okay, and this is the entire area. This area is called Bhadla Solar Park in Rajasthan. Okay, the entire area would be spanning across some 100 square kilometers, and currently has on the order of 5 gigawatts of installations in total. You can see there are so many. This is a small plant relatively compared to other larger plants, and there are so many such smaller plants spread across the entire area. So this is another level of modularity, like when multiple blocks combine to make one solar plant, and the entire power is evacuated from this plant. In this area of Bhadla Solar Park, we have power grid providing us high voltage DC lines for evacuation to load centers like Mumbai, Delhi, Bangalore, Hyderabad. So this itself is also kind of a modular, multiple plants feeding into the grid. So you can see the modularity starts right from the cell level till the plant level. So if we had sufficiently powerful telescopic satellites, you could just zoom in on one of the plants, and eventually you should be able to see the cell in that. So that kind of modularity, like a fractal, is definitely visible in solar, and that is very helpful. Now coming to the helpfulness to our sustainability housing, which is the theme for Shunya, how is it helpful? So this is a modular system, and it fits very well with the latest precast technologies, modular technologies in construction. So if you want to integrate solar with the precast construction technologies, it is very easy, because by very nature of it, the solar is modular. So let's look at the next feature of it. So there are no moving parts in solar, and you see an asterisk sign because there are some systems that go for tracker. Roughly, they are 5 to 7% in today's date, but majority of 90+% systems are the static systems. They do not have any moving part. And why is that important? Because if you look at any other electricity generating source that is deployed at large scale, uh, all of them have a moving part. Basically, you are finding a way to spin the wheel, okay, to spin the turbine. In hydroelectricity, we use the potential energy of water to spin the turbine. In steam generation power plants, which are either powered by coal, natural gas, or nuclear, we just boil the water, steam, and in windmills as well, we use the velocity of the wind to spin the turbines and generate electricity. But no such thing happens in solar. It is truly a static form of probably not possible for other technologies. Like, let's say, even if we tomorrow make a very small natural gas turbine that can generate electricity on your roof, but it will be very uneconomical to maintain it, because so many distributed turbines will be very difficult to maintain, as moving parts wear out, they need maintenance. But in case of solar, that is not the case. It is stationary. All you need to do is just wipe off the dust that settles on it. So that's why this lends itself to even installation on your rooftop or any such static features. As a matter of fact, even facades, as we will cover in coming slides. So this is a very large advantage, and we'll look at some more in coming slides. So I'll show you some pictures of solar power plants. So this is a 45 megawatt solar power plant by Sterling Wilson near Parali. So Parali has a 700 megawatts of coal fire power plant. Okay? But it is generally shut down throughout most of the year, and or even if it is operating it operates at very less capacity, because this being a water prone, drought prone region of Marathwada, you do not get water for irrigation. So water for power generation is out of question. So but you have solar that can still function in such an environment, because it does not consume as much of water as coal power plant. Then next we will see some residential systems installed. So this is a picture from Gujarat. Gujarat has very forward-looking policies for rooftop solar. So they have very good installation base in terms of solar at household levels. So you can typically see there are 4 panels, 6 panels, 12 panels. Such kind of systems are sufficient to power our home, and it's really no brainer now, thanks to the reduction in cost, that people can go solar at whatever scale they want. So next, this is something quite interesting. So in India, we have world's largest rooftop solar power plant till now. It will soon be overtaken by others, no doubt about it. But for a brief period, we do hold that distinction. So the roof that I'm circling over, this is 11.5 megawatt on a single roof. Okay, and the other solar plants that you can see on the red roofs, these are also in the same campus. So this is basically a dera in Bias near Amritsar, and it is Dera Bhai Jamal Singh, and totally they have 16 megawatt of rooftop solar in the campus, and this single roof is 11.5 megawatt, which holds the record of single largest rooftop solar at currently. So they have it is a grid connected system, and this is a satsang hall basically. So the entire campus activities run on this, and they supply power, excess power out to the grid as well. Now, next one is quite interesting. This is somewhere you see the true power of solar coming into picture. So solar is a technology where unlike others, where you can actually put it at the point of use basically. So if you need to use electricity at that location, you can actually generate it if you have enough solar radiation available. So this is a Futal monastery in Ladakh. It's one of the most beautiful things you will see if you travel in that area, and it has roughly 50 to 60 monks staying there. It's a 700-year-old structure, and people here did not have access to electricity in the traditional form because it is uh, uneconomical or unviable, you could say, to take power lines to this remote location. But solar lends itself beautifully in this, and you can see I've encircled a few places. There are some others which are not visible in the image, but these are typically small solar panels, 1 panel, 2 panel, 4 panels, something like that, and they have created a microgrid in the monastery itself. So we have seen many microgrids in rural areas and all, but this is a shining example of microgrid that is put up in such an inaccessible location, and still it works perfectly fine. So I would recommend, if anyone is interested to know more, there's a documentary called Lighting the Himalayas. It's available on YouTube. It's quite interesting. They've shown the procedure of putting it together and what hassles they had to go through this. And you can see at the end of it, people are so happy to finally get electricity. And it just shows you the power that solar has to transform and make impact on people's lives. So do check that out. And the next, I will share with you something that we actually go on a work visit to. So this is a Hanle observatory. It's an Indian astronomical observatory. It's situated at 4,500 meters above sea level. Okay, so it's very inhospitable climate, so to say, for humans to survive, but it's excellent for observing the universe. The skies are clear, the air is thin. So when they built this way back in 2000, it back then they installed solar panels because uh, it would be again uneconomical to put power lines to this place. Okay, but solar again works beautifully because at the point of use you can put it up, and in the next image you can see it also looks quite uh, uh, beautiful in the terrain. You have multiple instruments and you have large array of solar panels, and they also added the second array of solar panels when they added few more instruments, so that modularity and point of use both can be seen, which are very interesting characteristics of solar that you can use. So yeah, so we'll just take a small 5 to 10 minutes break if you guys have any questions on this section, so we can address a few questions and then we can move on to the next section. So with every section I'll take a break 5 or 10 minutes, so that if you have any questions we can address it and then move on. So Akash, do we have any questions in chat box?
Use of the solar energy is too expensive. Is there any way to reduce the expenses of solar energy, basically for poor reason?
Uh, Sure. So, I mean, solar energy was expensive, I would say. I mean, this statement would be factually correct 5 years back and before. But today, if you see, there are systems that are very low cost and which provide you very good electricity. Now, it becomes expensive for a reason. I mean, if when you add battery to the system, the battery adds cost as well as maintenance to it. But if it is justified, I mean, let's say it's a remote village or someplace, it is actually much cheaper than actually putting up power lines to that place. So the trade-off, if you see, instead of putting the power line all the way till there, it is comparable or cheaper at times. Like I showed you in so many locations in Ladakh, it is actually cheaper to put solar. So it is only matter of the matter of the logistics that how do you put it.
Okay, next question. Is the material available that repels dust and dirt so solar panel does not require cleaning?
So as of now, there are no dirt repelling material as such. Okay, there are water repelling materials which makes cleaning much easier. But yeah, I mean, to put it shortly, there are no dust repellent materials. But yeah, you can definitely, there are some anti-soiling coatings they call it, but those are actually hydrophobic coatings which actually repel water. So with the water, your dust is carried away much easier, and you need not uh, like if it was going to take you 2 hours to clean, it would probably take you 1 hour because the coatings help you in cleaning.
There is another question from Akansha. In Rajasthan,
Okay.
which type of panel can be used, either mono or polycrystalline?
So the logic behind this is basically on thermal side. So generally polycrystalline materials do not heat up as much as monocrystalline, but the advantage over that is actually negated because of higher efficiency in mono. So both of them are today, you can see in Rajasthan, you can see all types of modules being put up. So that difference is anyways gone. Like price wise, there is not much difference anyways, and the thermal performance gain that you get because of polycrystalline material, that gain you again get because of higher efficiencies that we are now seeing in monocrystalline, and with added high efficiency technologies like PERC and others.
There is one more question from Jivesh. We usually see the pros of solar system, but to every coin there are two sides. Does solar has the other side? If so, what they are?
Yes, I mean, definitely there are cons to it. I mean, first and foremost, the energy required to make the solar panel is not negligible. It is significant. So typically, a solar panel would have to be on field and generate energy for up to 6 to 7 months to actually make up for the energy that was required to produce that panel. So it is not a zero, how do I put it, zero energy proposition to make the panels. Secondly, there are also materials involved that are used during solar manufacturing. There are some hexafluorides that are used for etching of the glass, which are not really, how do I put it, they are not eco-friendly, so to say. So there are definitely other things like materials and in the processes which are questionable, so to say, about the uh, eco-friendly characteristics. And the worst is yet to come, I would say, in terms of negative, is that how do we dispose the solar panels? I mean, if we just put it in landfills, then that would be the sad state. I mean, we still have time for that. I'll cover that topic towards the end as well. So that is, we can stop it from becoming a problem if we start working now on disposal of solar panels.
Yes, there is one more question. What percentage of energy of India is the solar energy, and there are sustainable energy which can be helpful in remote villages in India?
Sure. So currently we have about 89 megawatts of installed capacity out of the 373 megawatts as renewable capacity. These include wind, solar, small hydro, and bioenergy kind of installations. Large hydro power plants are not typically considered as renewable energy by classification. So yeah, I mean, you could say we are roughly uh, 1/5, that is 20% renewable capacity. The entire share of renewable energy in the final energy would be little lesser. It would be close to around 10 to 11%, again, depending on what resources are available. But yeah, I mean, that is the breakup. And in terms of remote villages, definitely solar is one. As you have seen, solar can be used in remotest of the places where sun shines. So in India, we do not have any lack of sunshine anywhere in our geography. So solar is definitely one thing. To supplement, we should definitely look at having wind as well as maybe biomass as supplements to make it a reliable source. And of course, when I say solar, it is imperative that in such cases there is battery that comes with it. I mean, solar itself is only during daytime. Batteries are necessary, so solar plus batteries is something I assume it will be there when you are thinking about remote locations.
Okay, there is one more question. If solar is so efficient and so effective, why is it underrated, and why traditional sources of the energy aren't replaced right away? Like, are there disadvantages to solar?
So I would say yes, solar till 4 or 5 years back, solar was actually quite expensive. To be very honest, like it did not make economical sense to put up solar 5 years back, 6 years back on small scale. Large scale, it was still fine. But today, like that is the advantage of technology, that it improves every year and efficiencies have improved. Manufacturing costs have gone down. So solar is so cheap now that today actually solar is taking over the traditional sources, in the sense we are not replacing the old ones because we have already made those investment, everything is there in the place and all. But India has actually scrapped the plans for 15 coal fire power plants, and we are planning to replace it with solar, wind and batteries. So that is already happening. And it is and these assets, the energy generating assets, are typically made for 25, 30, 40 years of timeline. So if something was made in 2010, it won't be scrapped in 2020. It will at least function 2030 or something. But the thing is, the role of these assets are going down, and we can see that day by day. And anyway, solar, wind, these kind of renewable sources have priority to run. So we are giving them the due priority that is required. And our government is also taking steps, in the sense they have announced that the older power plants, which are older than 25 years, will not undergo any repair, maintenance or refurbishments. They will just be scrapped when it comes to that, because we are growing constantly on solar front, and the coal fire power plants are going out of favor. So one interesting thing I would like to put out here is, it roughly takes 5 to 7 years to build a coal power plant. Okay, whereas similar capacity of solar power plant can be put up in 2 to 3 years. Okay, so it takes quite a long time to plan for coal fire power plant. So the future additions that we were going to do, we have already scrapped it. Whatever was existing, we will have to retain it for some time. That is out of economic necessity, and I mean, no other logic to it, honestly, because solar is cheaper, and the electricity is also comparable to the cost of coal electricity today.
Okay. Due to time constraint, we will take one last question and go ahead with the session. Other questions will be taken care again in the next question answer session. Okay. If solar is using, next question, the solar is using up and the solar energy which falls on the earth and reflect back to atmosphere, will that affect the cycle if the solar system is deployed at large scale?
Uh, okay, so it's it's somewhat. I would like to put it differently. So yes, even if you look at the calculations we did it at the beginning of the talk, so it's not a significant area. It's just 1% of the land area. Okay, so overall, even if for the entire globe we do it, it's not going to be significant area to cause the changes at that atmospheric level. And true, I mean, the solar panels absorb light instead of reflecting it back. but what we are comparing it against, like coal power plants or other thermal power plants, these actually emit greenhouse gases which absorb more of solar energy that is reflected. So in that sense, we wouldn't be harming the atmospheric temperatures any more than we are already doing it now, I believe. Okay. So let's move forward. I think we'll go to the next section, and we'll come back if we have any other questions. So, let's go to current opportunities in solar photovoltaic. So before that, yeah. So this is something. This section is something that will deal with current opportunities in the sense. Let's say you are passing out in the coming year, or you are graduating in the coming year, or you're looking for a career in solar in near future. So these are the trends where you can probably put some effort, learn a little more about, or if you want to start a business in solar in coming months. So this is something. These are the opportunities you could explore. Okay. So one is floating solar. It is a very interesting application of solar, wherein you put solar modules on top of a water reservoir. Okay, so this does two things. One is it reduces the evaporation from the water body, and second, it keeps your panels also cooler. So it's an added advantage. And why this is being explored in first place is it reduces our land requirement, right? So land that otherwise have been used for solar is can be used for other purposes of currently the modules are the ones that are used on ground mounted systems, but there are efforts on global level to come up with standards and materials specifically dedicated to floating solar, which are better suited to this, like more corrosion resistance and lower reflectivity, such kind of things. So next is solar water pumping solution. This has always been a solution from long time, but in India also there is a PM Kusum scheme that government had launched last year, and in this they are envisioning to provide solar pumping solutions, solar water pumps to farmers basically. So because agriculture is one of the main sectors where the electricity distribution companies actually lose a lot of money in providing power to the farmers, but solar can actually very well do the same thing. And in the left hand top corner that you see, this is a solar pump installed in Run of Kutch. Okay, so there basically these are the salt pans of India. They pump brine water from underground brine water, and they put it on surface and let it evaporate, and you get what remains is crystal salts at the end. So the enterprising community that they have already moved on to solar way before. Earlier they used to use diesel generators, which was costly and also dangerous, but now they have totally moved to solar because it suits their application very well. The one on the right image, you see that this is a typical solar pump that is implemented everywhere. And the one at the bottom is a lot of ponds, especially in Maharashtra, in drought-prone regions. They have gone for farm ponds to increase the water level during summer seasons, so to have availability. So instead of putting up solar panels on land covering your cultivable area, you can actually put the same panels on top of your pond in floating system and actually save that area. So these are some solar pump examples. Again, a very bright opportunity if you want to grab it. Then the next one is we'll move from farm to the dense cities where you have high rises. So it is building integrated photovoltaics. So typically your solar panels are put up at an angle that is equivalent to your latitude angle for maximum gain, and it faces southwards, okay, to get maximum energy out of it. But now the price of solar panels has gone down so much that even if they are not generating at optimum, even if they are not placed at optimum angle and they are not generating maximum power, it is still effective in some applications, and that is something you can see here in building integrated photovoltaics. So the image that I'm showing you is basically a data center in Mumbai. So it is run by a company called Control S, and they installed all of these. The facade that you see are actually solar panels, and these are panels from Wari. Uh, they have also given us the split of how much they have installed on what face. So southeast facing, they have installed almost 300 kilowatts. Southwest, they have installed 260. The northern phase receives very less sunlight. So in that sense, they have actually installed only 60 kilowatt on the northern side, and northwest, again, they have installed something 250 kilowatt. So total installed power of the solar panels on this. So they have installed 2,500, close to 2,500 panels here, which are 350 watt peak mono PERC panels, and the size comes to around 860 kilowatts. Okay, so with this, they are generating 40 megawatt hours per month. If this exact system was actually installed on a latitude angle in the optimal way, you would actually generate at least 2 times more, actually more than 2 times of this energy generation. But it is still economically viable for the data center because they pay significantly higher rate of electricity, and their savings even with this kind of installation would be around 36 lakhs per year. So it's not a insignificant saving, so to say. Okay. And one more thing they have used in this installation is power optimizers. So what happens when you're putting up modules like this? So let's say these trees will cause some shade at some time during the day on the modules behind it. Okay. So that is going to lower our generation of those modules for particular time, so that it doesn't affect the generation of other modules which are not shaded. They have used power optimizers. Basically, two of the modules they have connected to one power optimizer, and that will try and extract maximum power from each module. Okay, so that is the function of power optimizers. And in such building integrated photovoltaics, we will typically use power optimizers to reduce our losses. Then next is something I call the other BIPV, that is balcony integrated photovoltaic. So this kind of system is fine where you have office buildings that have glass facades and all. But what do you do when you are going to residential side of things? So there are some really interesting examples that you can see. So in the balcony, instead of railings, people have been using solar photovoltaics. These are typically glass modules, they are called. So on both sides, they have glass. And in between, there's a sandwich of this solar cells. And all of it is clear so that it can let in some light also. And it looks aesthetically much more pleasing. So I'll show a few more examples of this. So you can see it is only the imagination of the architects or the designers to think how you could integrate the solar in day-to-day activities. And it is not negligible generation. We saw if we are able to put 3 panels here, and some houses in Gujarat had 6 panels that would generate and everything for them. So we are actually covering half of the energy requirement of the household, right? So one final image I'll show. So this is a building in Helsinki in Finland, and here it's very close to Arctic Circle. Okay, so they have actually very less radiation compared to us. But even with that, they are able to generate 1/4 of the requirement for household through such balcony integrated photovoltaics. In our case, I would be very comfortable in saying we can generate 40 to 60% of our energy requirement through our balcony integrated photovoltaics, if such a thing can be implemented. And it does not require any extra space. Everyone can have their own system. I've seen a few building integrated systems that are coming up, but this is still a new concept, whereas other places they have tried it. let's see if we can get some systems like this ourselves also. So the next one is a canopy. So let's say you want to create a shaded area for whatever reason. So instead of going for a tin roof or a GI sheet roof, you could go for solar. It definitely looks aesthetic as well if you do it right. And it's not just passive component sitting there. It could be an active material that is generating electricity for you. So this is typically a restaurant setting that can be seen in this image. It has a nice solar roof with, again, glass to glass clear panels, so it lets sunlight percolate and gives a good vibe, as well as it is generating electricity for use at the point. So these are some opportunities that we can use. Even these are some implementations that we can do even today. We need not wait for any breakthrough to happen. And the last one is the solar carport plus EV charging. So EVs are electric vehicles are basically picking up slowly in our country. They are already picking up very well in Europe and US and especially China. So the next thing that we are looking in our clean tech revolution in India is actually electric vehicles. And the question comes, where do you charge them? So this you can see is a supercharger location from Tesla in California. They have close to 40 stalls, and most of the energy that is required for charging is actually generated on the site using the solar panels. So they, in the parking lot, they just created the solar canopy and solar carport, and they are using the same energy to charge. So this will be one of the larger things coming up in India as well. So I mean, if we generate so much extra solar energy, where do we put it? So this is the ideal way, I believe, that we will be going forward. So so this is another slide I would like to show you. Like the line that you see connecting is actually the data has been there till 2018 when this chart was made. So we are already in 2020. So this shows the capital cost required to put up solar in USA. This is not for India. In India, we do bypass some of the uh, basic electrical safety concerns, and that's why our costs are generally little lower than USA. But you can see it was about $5,000 to put 1 kilowatt of a system, which has come down to $1,000, maybe a little lower, 800, 900 as well, in past 10 years. And our experience has been the same. So if we look at megawatt level scales in India, in 2010-11, when the earliest large scale plants were being put up, the cost of putting up 1 megawatt was close to 15-16 crore per megawatt. And it took about 4.5 to 5 acre area to install 1 megawatt. Now, coming forward, looking at it today, the cost for setting up 1 megawatt power plant is actually somewhat lesser than 3 crores. And the area requirement has also reduced thanks to improvement in efficiency. So you can put up a 1 megawatt plant in roughly 3 acres, slightly more than 3 acres, and less than 3 crores. So we have seen tremendous improvements in capital cost for solar. So the question, as I said, was very valid that solar was costly, but the question now is outdated. Now we should be asking, what can we do more with the current cost of solar? And the story doesn't end there. I mean, the projections are the solar cost will go down more and more because of improvements coming up in the technologies and efficiencies in manufacturing, as we are learning more and more how to manufacture at large scale. And the projections are by all means that we would come somewhere close to 200 $250 per kilowatt hours by 2030 in USA. And that is another basically 4 times decrease, which would be like entirely revolutionary. At that point, it would not make sense to put up anything else. It's going to come to that. So yeah, so this was the second section. So if we have any questions, we'll just take them quickly.
Hello.
Hello. Yeah.
There are questions from Google Sheet. As compared to solar, the wind and biomass are cost effective or not?
Yes. So wind energy is cost effective at locations where it is available. Basically, not all locations are equally blessed with wind as solar is. Like, so solar is uniformly distributed, roughly uniformly distributed, you could say, across our geography, but wind is not. So where there are more hills and hilly regions, the wind energy is much better there, rather in instead of more in the plains. So yeah, that depends actually for wind. For biomass, it is if because of fuel again is free for you if you have cow dung and other organic sources like uh, leaves and crop residues. So that makes sense where it is available, definitely.
Kedar, there are some more questions asked by participants at the timing of filling the Google form. Can we take some of them?
Sure, sure.
Um, why is the solar is still underrated, knowing its immense potential? What are the some problems a consumer faces if he wants to go solar?
Okay. So there are some issues still. I mean, technologically, I think I would say it is solved, but there are still a lot of problems in terms of policy. So especially because people who can afford to put up solar today, right, are the ones who are actually regular paying customers for the distribution company. So they do not want to see the revenue loss from this. As I said, these companies, this electricity distribution companies, have to give power to free or at very subsidized rate to agriculture and to low energy consuming households. So the ones that are actually going to use large amount and they go solar, so their revenue is going away. So that's why they create some kind of hurdles, like they are not very receptive of people putting up solar, and if someone actually wants to, they make it so difficult, like there are 10 forms to fill and 3-4 visits of people, and such things which are kind of discouraging in nature. In spite of that, I would say we still have thriving rooftop solar market. So I mean, people are finding a way out. But yeah, I mean, that is one major reason why like you are not seeing so much of uptake on rooftop solar, because the distribution companies are actually kind of hampered. Their business is hampered because of it. So they are not very receptive of such a thing.
Okay. Next question. Application of the solar PV in microgrid and power grids. What are the application of solar panel in microgrids
Okay.
and power grids? Yeah.
I think we saw this very well in the Ladakh example, where even the monastery, where there is no other way to actually power it solar, they formed a microgrid. Even with the observatory location, they put up some solar, and that is powering the entire premises. Such applications are always possible. I've shown you the most extreme ones. The simpler ones are actually the ones in our small villages, you can say, where there is no power or intermittent power, or small hamlets where there is no power grid yet. So microgrids are very easy to put up in that location, very economical as well, I would say. And they are very robust. I mean, once you install the plant, it should function for about 15 to 20 years. The solar panels, the batteries, depending on the nature of battery, may have to be replaced once, and with very little maintenance. So microgrids are great solutions for those locations.
What are the career prospect in this domain, in solar domain, like a job opportunity, internship in India?
Okay, so there are quite a few job opportunities available. As you see, I mean, we have tremendous potential. So our goal uh, by Indian Power Ministry, that was put out a couple of years back, there was a study. So we are expecting to have 300 gigawatts of solar. So if you remember, we have 370 gigawatts of installed capacity of all types of generation, and we are planning only solar would be 300 gigawatts by 2030. Okay. And today we have installed 38 gigawatts of solar. So there is 9 times more that we have to do. So if you see by the amount of work that needs to be done, there are tremendous amount of career opportunities, definitely, as well as internship opportunities. So I would say in terms of career, you could join small or large installation companies, operation management companies. So many varieties are there. And in terms of internships, again, it is the same. If you want to look at entrepreneurship opportunities, those are also quite popularly available in solar. So it's very low cost to start your own solar installation business. You don't need to invest much initially, except like if you are there are some sensors that I use, and there are uh, some systems without sensor as well. They are just coded to be at certain angle at certain time. So yeah, I mean, with or without sensor, you can do it both ways.
What material properties should be required to be suitable for use in floating solar?
So in floating solar, basically we are observing a few things in terms of the encapsulant material. So uh, basically the solar panel that you see is actually solar cells are laminated in a transparent sheet like a regular lamination. It's called EVA, and then you have the white back sheet, and on top you have the glass. So there is still a possibility of moisture ingress instead of EVA sheet, so that uh, we have much more moisture tight seal. And in terms of structures that are used normally in ground mount systems, we have steel structures, galvanized iron or galvanized steel structures, which are used. And in floating solar, it's basically HDP, that is high density polyethylene blocks. So it's basically blown to a size and shut off. So you enclose the air inside the plastic bubble, and that creates a floating structure. So yeah.
By 2030, approximately what could be the efficiency of solar panel, and what is the future of solar tracker in India?
Uh, so if you look at it, typically year on year, the efficiency in solar panel is growing by about uh, 1 to 1.2%. Okay, of the existing one. So you can compound that. I would say today in 2 by 1 form factor, we get 350 to 360 watt peak modules in 2 meter by 1 meter size. So I would say in 2030, and this is purely a guess, there is no right answer, I would say, but you would definitely see somewhere close to 450, even 500 watt peak possible. There are technologies that are that can be applied and get those results today as well. And you do see there are quite a few modules that are reaching those levels. But again, then you have to pay the premium for getting that higher power. So I would say this would become the norm. Like today, we have 350 to 360 watt peak modules available at lowest possible, like at competitive price. I won't say lowest possible, but at competitive price in the same vein, we would get 450, 500 watt peak modules by 2030 for sure. And solar trackers are feasible even today. So I mean, but just that the added complexity that comes with it, the mechanical complexities of moving parts, is somewhat of a deterrent. Uh, yeah, but I mean, if the case is strong, business case is strong, then people can go for trackers. Even today, there are available tracking systems. I've seen some tracking systems at megawatt level plants in India as well. So they are definitely there where land is constrained and you want to generate more from the same area. Trackers are very good way to increase the yield per acre of your field.
One last question. What are the material properties would be required to be sustainable for use in floating solar?
I think we covered that, right?
Yeah, okay. Yeah, okay. Yeah, we can continue then with next session.
Okay, sure. So I think we are doing well with the time. So we'll cover up the session and then we can come back to question answers later. So what are the future opportunities that you can see in solar? Okay. So one is O&M services. So in large scale power plants, the cleaning of modules and everything is quite either mechanized or it is very well organized, because that whole bread and butter is dependent on having good generation. But in terms of residential solar in the cities, typically systems are not cleaned regularly, or they are not attended to well. So there is definitely a business case to be made if to have a O&M service for solar modules in residential or rooftop settings. So something like maybe an urban clap like solution for solar. So that is one something if someone wants to look at. Then the next one that I'll like to share is the new technology. So why I'm sharing this slide? Okay, so here you can see these are these solid square line, right? The one I'm tracing, which goes up to here. It this is the current technology that is most popular. It is crystalline silicon. Okay, and it took about uh, 45 years to reach to go from 14-15% of efficiency to 20-22% efficiency, and it requires heavy capital investment in putting up these manufacturing plants to make these solar modules. But interestingly, if you look at this particular uh, technology that I'm pointing out, the red circle with yellow dot, with yellow fill, these are called perovskite cells. Okay, and these were demonstrated to have photovoltaic property around 2010. Excuse me. So, but you can see the rapid growth in the efficiency of this cell. It started off at around 12%, and in just very short span of 15 years, it has become comparable to silicon cells that are available today. So this technology is something that is that can be used for roll-to-roll printing. We call it roll-to-roll printing. Basically, it's like your printing press. The way your newspapers are printed, you could print similarly these solar cells in large paper-like stacks, maybe on plastic substrates or something plastic clear plastic substrates, and you can generate entire roll of solar panels, and very easy to deploy, very low cost. So these would be some things that you can look at in coming years. Also, there is a case to be made for a higher efficiency module. So this is typically what we are seeing at 20 to 20, between 20 to 25% of efficiency is something that we are looking at for residential or energy generation perspective. But you see, there are some higher efficiency cells also available. These are typically used in space applications where actually the cost is not a constraint, but the weight and efficiency, you would want lower weight and very high efficiency. So those become our constraints in space. So there are some terrestrial applications as well where this could be used. I'll cover it in coming slides. So there is a case to be made that these are triple junctions or multi-junction cells that could be used, and they will have very slow demand at first. So if someone is actually interested in investing in manufacturing side of things, So there is no point investing in the current manufacturing if you're starting from scratch. I mean, because already the market is very saturated. China adds ton of manufacturing every year. Even in India now, we are seeing a lot of people adding manufacturing because we are putting up tariffs. So this is current thing. It's very capital intensive as well. But if you want to start small, these are a couple of technologies that are coming up or already there, which have their niche applications. So this is something I just wanted to cover. So another interesting upcoming future application is solar roads. I'm sure everyone has some maybe read or heard about it sometime. So this is a solar road that was put up in France in 2017, and they conducted experiments for about they collected data for about 1.5 years on the same. And the current generation, this was the first generation of the technology, and there was a significant failure. I mean, the generation went down very significantly initially. So in the current form, the technology is not quite uh, uh, adaptable for solar roads per se. So there are some other experiments that were put up simultaneously in other countries. So one was they put up solar on cycling tracks. So where it survived better than this. So it definitely means that if you want to like if you want the road to carry heavy vehicles, you need to upgrade technology, or you use solar roads in something like cycling tracks or some place. So either which way, I mean, this is a very interesting application coming up, and people are so hell bent on wanting to come to a solution like this that a lot of money is being poured into it. So I'm sure we'll see something in next 3 to 5 years, some next level of technology, next generation, and it will continue, I believe. Then I was talking about high efficiency cells, and this is where it could be applicable. So the solar electric vehicles, basically, you put solar cells on top of your electric vehicle. So you generate at least some portion of your energy from your surfaces of the car itself. So this is a Lightyear 1 sedan that is this company also was incorporated a few years back. The team is coming from solar racing events that are conducted in Australia. So they have a solar racing competition where student teams come and participate in different categories. So like what is the farthest you can go on one charge, and what is the fastest, and such different criteria. So one such team uh, came up with this car as a consumer product, and they also received some amount of funding to do it. And this is where I would say a higher efficiency cell would definitely be a business case, very valid business case. And if you think about it, like if we are able to generate at least even 10% of our energy requirement for our electric vehicles from their own surfaces, that is 10% less of a strain on the grid, right? So it makes quite a lot of sense to think about this, and there are many solutions coming up. Even the e-rickshaws that run on many cities, people are just putting up regular solar panels on top of it, and they are generating 10 to 15% of their requirement. So that's a very good business case, as well as a very good use of solar, I would say, again at point of use. Uh, then I think we are all familiar with our calculators having solar. So there are many more such products coming in, like your remote control that will have solar. Maybe your digital wall watch will have solar. So such things, because think about it, we use so many cells, battery cells, in these kind of disposable applications. And if you have solar integrated with such devices, small devices, you could actually use the same cell for maybe, instead of 1 year, you could use it for 3 years, 4 years, or it could also be perpetual working machine for all you know. So yeah, these are some really interesting applications which could be coming into consumer side of things. Like it's not large scale solar, but it is using solar to do some simple things. And so there are now we see a lot of IoT based devices coming up, right? Some sensors and cameras that can detect weather patterns and okay, so the ones that we use as our LED bulbs and all, uh, that light can also generate some amount of electricity for these devices, and it can run these devices for very very long time. So then next that is coming up, and I think this is a great opportunity both for entrepreneurship as well as improving livelihoods of many people, is solar desalination. So we typically hear about so many people traveling large distances carrying water for their family, and because they do not have access to fresh drinking water nearby. So we can have a decentralized solution like this. This is a installation by Give Power in Kenya. So this installation produces 25,000 liters of drinking water, okay, per day. And typically a person consumes around 3 liters of water per day. So you can consider this system is providing water for about 8,000 people. Okay, so we can definitely put up such systems where we use solar pumps basically to take underground water, desalinate it, and give it out as fresh water for people. And it could be done for so many villages. It can be a decentralized solution. You don't need to put pipelines for kilometers and kilometers. And I think the cost wise also this would be quite efficient in the same. The next one is another interesting solution for rural sector. So in India we lack the infrastructure for agriculture, right? I mean, if you are growing perishable crops like vegetables or fruits or something, the farmer has to instantly sell it out, or the yield will go bad. So what we can definitely do is we can have a standalone system. Like here you see the solar panels are generating electricity. You will have the compressor and energy storage mechanisms inside, and you can provide a cold storage. Maybe the wealthier farmers can buy such a thing, or it could be a business case where you could just provide the area like on per day paid basis to the farmer to store their perishable yield as well. So the next is something we'll come to uh, towards the end of solar panels life. So what all could happen? So there are a lot of discarded panels. It could be discarded for various reasons. One is it is not measuring up to the performance or standards or something. So you can convert it into some furniture. Like here you see there are some tables that have solar panels, and uh, these solar panels do produce electricity even at this stage, albeit it might be lower. So you can use it for low power applications like charging phones or something. And if you have panels that are totally discarded, like they are at the end of the life, or there is some mechanical or electrical fault, and you don't want to put it up in a consumer setting where it could cause like a shock hazard or something, you can use it as a building material as well. So this is something ISC Bangalore team has been working on. They're using discarded panels as structural elements in building. So because the aluminium frame provides good amount of strength, and it has glass surface which can be used. It's not a strength providing material, but as a surface element. So these are the ways people are thinking of upcycling. I would call it upcycling at end of life. For the module, because it otherwise the only other way is to recycle it, which is again a little bit energy intensive. While that is the next point. So PV module recycling is something that is going to be needed in very early years, I would say in 2025. So typically, the solar modules are set to last for 25 years. But our research shows that because of the tropical nature of our country, very high heat, the panels actually degrade much faster. So I would say we are the life of solar panel in our conditions would be close to 15 to 18 years. And at the end of it, the generation would go down so much that it would be economical to replace it with the newer new generation of panels. So the panels, large scale plants that were put up in 2010-11, I would say would start generating the scrap by as early as 2025. So we need to have mechanisms in place that would generate that would recycle these modules and not generate as much waste. Even at, there are already efforts being put into recycling. There are some companies who are trying to do it on large scale, but it is still the first generation of technology. There is always scope to improve this, because even at the end of recycling, there's some material waste like that cannot be repurposed or reused in effective way. So there's always a scope for that if anyone is interested in pursuing it as a long-term strategy. So this will definitely be a very huge market coming up soon. So, and this is probably my last slide for the presentation. So, and I would like to show this for a particular reason. We think solar is a relatively recent phenomena, but if you look at it, the earliest application of solar was actually satellites. Okay, and this is the very first solar satellite. It was Vanguard 1, launched by USA in 1958. And actually, the first crystalline silicon solar cell was demonstrated in 1954 by Bell Labs. So the story behind this was Bell Labs scientists wanted to integrate solar alkaline batteries that we use as a source of power. So the group of scientists that wanted to go traditional way said that, okay, we'll go for something that is way more reliable than solar cells, and we want to put up batteries in the satellite. So they included batteries as well. And when the satellite was launched, so the batteries typically drained out in a few days, and that was the nature of it. They were not rechargeable batteries; they were single-time use. So the satellite would basically stop functioning after a few days up in the space. But in case of Vanguard, because it had solar cells, it actually continued to work for 6 more years after the battery is drained out. And that after that, whatever is a history. Like every other satellite that goes up in space today has solar panels to capture sunlight and deliver whatever its results are. So whatever we use today in terms of technology for communications, like our direct to home television or our GPS. So these are all thanks to solar power that we are able to use it, because it would be impossible to put up such an energy generating source up there at the weight if it was not for solar. So yeah, we'll end with the final Q&A session. So I'll leave you with one more final device, and so this you can see here, these are solar diyas. They are actually on offer from Energy Swaraj Foundation. It is one of our professors, Chetan Singh Solanki, who is leading this effort. And for this Diwali, they have come up with this idea of having solar diya. So you keep it outside. Anyways, they are meant to light outside. So throughout the day they will charge, and in the evening they'll light up automatically. So yeah, looking forward to many more such innovations and innovative ideas in solar coming forward. So let's finish with a few questions if we have. I think we are right on time.
There is a question. What is your view on bifacial model in terms of opportunity, performance, and efficiency?
Okay, so bifacial modules are also kind of higher yield modules. So basically, whatever you could say sunlight is wasted, that is not collected by solar cells, it gets reflected and everywhere else. So the bifacial module can also capture the sunlight from the backside. So it can give you efficiency increment definitely, and in terms of energy increment, it can give you substantial depending on the nature of the installation. Like if you are installing in highly reflective environment like deserts of Rajasthan, you get extremely high albedo. It's called albedo, the reflected light. So you get very high albedo. You can get almost up to 20 to 25% extra power at peak. Okay, and it's basically free energy that we are collecting from the same module, you could say. So it's good. Again, it has to be designed for that application. That is all I'll say.
Okay. Due to time constraint, we cannot take more questions. We know, guys, there are some of your questions not answered. So can you please write us on iitb.teamshunya@gmail.com. So we will happy to answer them. Can Sakshi, can you guide to attendant? Hello.
Yes, I have put the link in the chat. Okay, so Kedar, thank you. This session was really interesting and thought-invoking. And I would also like to express our sincere thanks to each and every participant present here for joining us in our team's social awareness program towards sustainable houses. Hope this session was useful. And okay, so I'll be putting one more link that would be for feedback. You all have to fill that form and you will be getting certificates. So please write your name correctly, as only this will be there on certificate.
Okay. Thank you everyone from Team Shunya as well as the participants for sitting through the session. If you have any more questions, you can write it to the email. I'll answer them. I'll answer with a reply to the email. Okay.
Yes, thank you again, Kedar, for taking time from your busy schedule and for all these efforts. We are really grateful to you.